Today, we're going to start with going through a little bit of some marketing trends, challenges, why this is all very important. From there, we'll go into the platform, discuss the variation of the pieces, and then with that, we'll go into a small demo of the CLOUDLENS software as a service. So we've been doing a lot of market research over this topic for some time now, and a lot of this information was based on what was coming up this year. As you see, most of this, well, say starting with, clouds are everywhere. 93% of organizations are using clouds, and every single time I say cloud, I just want you to think virtualization. So cloud spend is increasing because we know that a lot of the market is slowly going into containerization, using public infrastructure as a services such as AWS and things like this. And we have seen the movement of about 50% of these applications going to the public cloud because it's very easy for companies to be agile, get their production environment up very quickly, and they won't have to manage it. That's why AWS and Google and IBM and Azure, they're all there to handle all that hardware for you and remove all that task from your business structure. So clouds are multiplying. With that, the virtualization is just growing and growing and growing. Let's say one key term, kind of going with Keysight's goal in the 5G test revolution. If you know a little bit about 5G, you may have heard about virtualized network functions or network function virtualization. So once again, virtualization, that means it's going to be in a cloud. Therefore, for us to go into the 5G revolution, we will be supporting clouds. So a little bit about clouds and this virtualization. First, we'll start at the top. We have the public cloud infrastructure as a service provided by companies such as Microsoft, Amazon, Google, and IBM. What this means is I'm going to give away a lot of responsibility of these servers and the AC and where these machines are going to be housed. I'm going to let these companies manage all that, and I'm going to have a small team of technicians just manage the UI for that platform, so I can launch any type of virtual machines, Linux boxes, Windows boxes, or applications that are already kind of pre-built.
John, we've lost your audio. John, we've lost your audio. John? Apologies everyone for the lack of audio.
Everyone hear me?
Yes, you're back now, John.
Sorry about that. I'm not sure what happened. Okay, so moving forward, the private cloud is going to be where you're going to be managing your own equipment, your own servers, your own everything from cables to air conditioning, and you will need to have the engineers and the teams available to also manage that. And this becomes quite a big task. And this is why many companies are slowly moving into the public cloud, I would say, area, because it reduces a lot of stress and allows you to focus on what you're trying to do actually, with these applications you're building, not so much how well am I at managing a data center and things like that. So anywhere I'm going to have my own hardware, my own servers, this is generally considered an on-prem environment. But as things are moving in today, we're not just seeing one side or the other, we're seeing both environments coming together and the need to have this accessibility from various data centers and various public clouds at the same time to have very successful real-time applications. Okay, so the future of the cloud, despite the big growth in the public sector, we're also seeing a growth inside the private cloud environment as well. As I was saying, when we're going to go into this containerization revolution and get into load balancing to multiple applications that are allowing us to keep a 99.9% uptime. All this technology is going to be necessary, and we're only going to see further growth in this environment. It's allowing us to be more successful in the field. So the market will start to move that way, I would say. So something that's very different from, let's say, networks and building applications from maybe 15, 20 years ago. At one point in time, you generally had like one office with a data center inside of it. Everything was there. You could walk across the hallway and, you know, communicate when you need to get certain things done. But in today's new world, the idea is that there's so many various types of access and tunneling and needs to have connectivity between various locations. And this is even more required now as we have the corona situation, and we have a lot more workers working from home, working on split tunnels, working just in unusual situations. And when we start making a lot of these temporary changes to adjust for such situations, a lot of mistakes will be made. So this is where, you know, having visibility is paramount in these situations. And if you weren't ready for that before, you're going to be spending a lot of time to get there now. It's convenient we have some good automation to help you get through this situation. So what are the drivers for visibility in the cloud? So we're focusing on collecting packets, collecting data so I can understand the performance of my environment and then also the security of my environment. The biggest thing to get here, packet data access is paramount. Log data and metadata access is also very much required. But with these applications, you need to be able to scale, because as we were speaking before, network function virtualization, the use of using 3 or more containers of which I load balance across to, when it goes to 4 or 5 or 6 containers, will my visibility solution be able to scale with these containers and allow me to properly tap and understand all the traffic as it's going through this? Also with that, infrastructure churn has a lot to do with change and moving between brands and moving between types of deployments, going from hypervisors to containers or stuff like that. We'll be able to help you through any type of change. And as everyone's probably aware, a lot of brands come in and out, and we've been around for a while now and still running this CloudLens solution. So the biggest point, it's hard to see the traffic in the clouds. Why? There's no wire. I can't grab the wire, tap into it, and extract that traffic to do what I will with it. This is all residing inside the hardware, communicating across its chips itself. So the point is, when I'm looking at east to west traffic, it takes a lot of configuration on the platform I'm using. So for example, VMware, to communicate, well, let's say
John, your sound has gone again. I'm sure everyone can understand the joys of working from home sometimes.
Can you hear me now?
Yes.
Okay, everybody's got me now. Very many apologies for that. Okay, so as I was saying, I think Claudia, you heard me up until the virtual private cloud.
Yep.
Yep, okay, so moving into the public cloud, as I was saying, from the virtual private cloud, generally hypervisor environments, you're gonna have to have an engineer who's very understanding of that environment to configure extracting this traffic from specific VMs, and it's not an easy task. It takes a lot of time. But then moving into the public cloud, once again, we're going to be faced with this very same situation. I need an engineer who's very, very specialized in this environment to understand how to make the configurations to extract this traffic to where I want it to go. And it's not going to be easy. It's going to take them 20 minutes to an hour or something like that just to get one thing done. And so it doesn't scale so well. And with that, we have applications now running inside of containers. And Once again, you're going to have to figure out some way to manually configure that container to pass that traffic, building your own mirror reports. The biggest point here, you will be doing it yourself most of the time. It's going to be very consuming on your time, and it's going to create quite a bit of load for your engineers. So the biggest point here, packet DAC data is the gold standard. Packets will provide you all the information. It tells you who was speaking, why they were speaking, when we're talking about, say, protocols, what they're speaking on top of. And this is the reality of what's actually happening between our applications. This isn't a drilled down version of what the logs that came out of the application. This is what was sent directly across the wire. There is no false inside of this situation. So 81% of let's say tools would prefer packet data for security and investigation, generally because again, you want to have everything, and especially when it gets to with confidence and being sure. You don't ever want to have that situation, well, maybe we didn't catch a certain part of the payload and we're not seeing some type of security alert that's coming up. 35% currently perform deep packet inspection and analysis. So a lot of these newer traffic analyzers have kind of taken in the idea that we must use, or going to use packet data. And so they can directly ingest it. They'll use certain plugins from, say, companies like Bro to take this and put it into a log format to ingest into a machine learning model so I can understand what's happening and start to develop some, let's say, trends inside of my environment. And what's very convenient about that situation, machine learning is based on having as many points on a graph about a certain picture of, let's say, a packet. So for me to make a clear understanding and differentiate between all the other packets that are out there, I need to have the most data. If I start to trim this down, I'm going to lose a certain amount of depth in this information and how well we can understand or make these machine learning trends and get better analysis and reactions from our systems. So as I was saying before, on all these cases, you're going to have to be very, very close to the platform you're going to be building on top of. And in a lot of cases, you're going to be building, and say generally, you're going to be building all of these platforms. Very, very common now. We have hybrid environments. Everything from people using virtualization on their personal computers, to having those data centers, to also having some AWS servers, because they're just really easy and quick to spin up and spin down. So how do we start to manage this situation if I'm going to need to have an engineer, or say a team of engineers who work on 7 or 8 different platforms, all work together? This could get a little difficult, and so the idea is to bring it all together into a single pane of glass with CloudLens. So as we were saying, CloudLens operates in all the cloud environments, all of the virtualized environments. We have the private cloud, which was originally built for the VMware and the OpenStack and KVM environment. So it's a hypervisor-focused environment. This private cloud deployment would communicate with the API of that system to do all the automation required and all that configuration I was speaking about before, so your engineers do not have to. We have the capability to go into hybrid clouds and containers, and also we get into the public cloud. So inside the public cloud, we're going to be doing a bit of a different deployment. We found that using the hypervisors created a bit of, how would I say, sometimes we had certain roadblocks due to the fact that the company that's building the hypervisor might change their API. Well, if they suddenly change their API and not everybody's aware about it, things can go wrong. And we were having certain performance issues. And so we took a step back and said, well, how do we get into this environment and allow us to be agnostic? So inside the public cloud deployments, we're going to be using endpoints that are going to create IPsec tunnels between the locations to pass traffic. This can be the full packets or NetFlow. With that, we have the, let's say, the virtualized concepts of the various stacks that would be coming from our network packet broker series. So we can do things like deduplication or data masking, or going in and, let's say, learning applications dynamically through AppStack. So
the benefits of our cloud visibility is that we're not using any type of single point to push the traffic anywhere else. Each endpoint is acting loosely and flexible as something that can send and receive anything to itself from anyone. So the point being is that we have a distributed model that has no single point of failure. It's going to scale automatically without limit. So say if you have, say some of other deployments will have a packet broker that'll sit there at the end. In some cases, this can be nice, but then when you have one pipe out, you have a single point of failure. So the point is, if your application also did scale up, and so you developed or you built the sensors and the endpoints are all deployed with it, or however it was done, the loads increased, is that other packet broker situation, can it also scale and roll up as that situation occurs? And a lot of situations not, because it requires a lot of configuration. So serverless architecture keeps costs low. Everything's pretty light. We're using the software as a service, so you'll just be reaching out to our cloud infrastructure that'll be ready for you. So it's very easy to get started. You don't need to worry about building your own server that sits somewhere. This will enable secure data delivery to solutions anywhere using the IPsec tunnels. And as we were saying before, you'll be able to manage everything now from a single pane of glass. Whether you're coming from VMware and pushing it to AWS, and then maybe going down to OpenStack. In any situation, you'll be able to get the traffic where you want it to go. So the Cloud SaaS was purpose-built for the cloud, and because of the need of that flexibility, and we wanted to remove the, I want to say, the single point of failure. That's why we developed the endpoint solution. Kind of going with this same idea, we also developed a container sensor solution so that we would place an endpoint on the container itself. We would, as containers work, they build multiple little interfaces to communicate across. We would just put one more on top of that, and then we would push that traffic out now GRE to the locations you require. So when an endpoint is placed on one of your machines, it's going to collect a little bit of data about that machine. This is going to be metadata. So what's the processor of this machine? What's its host name? What's its IP address? Things like that. We're not going to be taking any of the actual packet data up. This is just tag information, so I understand who I'm working with. Once we've ingested that metadata, which will include the key that's with your account in your project, we'll then be able to build either sources and tools to push traffic to where we wanted it to go. So how the workflow generally runs is, first we're going to identify the source instances. What are all of my servers and things that I need to extract traffic from? From there, I'm going to deploy my Docker container, and then I will start to group these, let's say, sources by types. Maybe I have a group of web servers, or maybe I have a group of FTP servers or something of that nature, and I want to tap and make sure, let's say, no one's trying to get on my FTP server maliciously. So I can group these various types of servers easily so that I can create a better ease of use for myself. And this could also be useful if you have, like, how would I explain it? A multiple, like say if I have a web server, it's generally not going to be in one place, especially if you're a large business. You're going to have a web server in maybe 4 or 5 different data centers across the planet. And you just might want to understand, well, how are all of my web servers doing, and what's the security of all my web servers, so I can grab everything together. After that, I'm going to identify the tools, or where I'm going to be sending this traffic to get to the tools. From there, we're going to create a tool group once again. So this could be a server farm. And after we draw a line between one point to the other, it'll just quickly build the IPsec tunnel. So in 5 steps, you can build this visibility setup. And inside the demo, I'm going to deploy and launch, and hopefully we'll be able to see the traffic very quickly. So just kind of continuing on with that, what we were saying before, we're going to group things by tags, by specific types of services perhaps, and then send them again also to specific types of tools where once again, we're generally going to have network performance monitoring and security, which both want this data. They will both want all of it actually. We also have been working on a solution with Azure, their virtual network tap, which would sit on the edge in the bottom left of this diagram as you see. From that point, we would have a, let's say, a group of CloudLens endpoints that would reside just on the other end of that Azure virtual network tap. Once again, as you see here, there's going to be a few different instances that are deployed to ensure we never have a single point of failure. As you would see from this Azure virtual network tap, if you were just to put a normal packet broker right there, and let's say the load starts to increase, will your visibility situation continue to hold? And allowing this CloudLens flexibility and scalability can be quite important to you for those situations. Very similarly, we're going to have the same type of situation using a AWS VPC mirroring. We'll go through the VPC sending certain information up and forward the traffic across. So again, going back over, we have container visibility. So if you have certain Docker environments that are hosting certain applications, as you would see here, we're perfectly capable of assisting you in that situation for your visibility deployments. And once again, Kubernetes as well. So as you see, any of the big names or major components of virtualization, we are inside of this already. We're ready to help you into getting this traffic out so that you can secure and understand your environments better. I'll move right past this one. So just give you a moment to look over this. So we have a very long-standing relationship with many tech partners. I'd say I've personally been working on CloudLens for probably 8 or 9 years since I joined the company back in NetOptics. And it went from NetOptics to Ixia to now Keysight. This is a product that's been going on for a long time. We know it's going to be a necessity for our deployments in the future. So we have a lot of strong relationships with other companies and support as we continue to move through this situation. So benefits of CloudLens, it's going to be elastic, it's going to scale on demand, it's going to have a very easy to use graphical UI. With the, let's say, the intuitive UI, the ease of use, and there's not so many ways you can misconfigure it, there will be less configuration errors, so you're going to save time, and that also results in the money. With your visibility now, you're going to get all of the traffic in all of your environments, and you'll be able to properly build the machine learning models to get the good analysis on this situation, so your security will be enhanced in the long term by this type of deployment. So here's a quick image. As you can see, this is the GUI for the CloudLens SaaS, where I would be, let's say, taking traffic from one point to the other. So on the left side, I would have my sources. I would see at the top maybe DB server or my Git repo or web servers or things like that. On the right side, I would have my different tools that would be interested in this traffic. Very easily, once I've brought in the instance, I would simply click on the tool on the source on the left, drag it across to the right, and the job is done. So if I have 100 sources and they were the same type, I can group them all as one. I make one drag across to the right, and my job is done. Okay, let's go on to the self-hosted. So next, we're going to go a little bit into the hypervisor tapping, the CloudLens self-hosted. So the biggest thing to understand from this environment, as we were saying before, we don't have access to the east and west traffic because it's not running across a wire. It's not going back out to the router so they can be spanned out or something of that nature. This is all communication that's happening internally, and we need to get that traffic out once again to develop an understanding of both performance and security, because generally, let's say you might have a web server and a database and an FTP server that are all inside the same system, communicating with each other. If one gets attacked and in its kill chain it starts communicating to the other ones, how would you be aware of that situation? There wouldn't be a very good, easy way to do that. It takes the visibility. It takes extracting that packet data. So with this, again, going back over the information before, we have these pieces that fit into this whole CloudLens self-hosted platform. The vtap, which will be the virtualized tapping automation to go into the hypervisor and help you do the job for you. We have packet stack, so we can start to do a bit more of the interesting packet manipulation that we would see from the packet brokers, such as the Vision 1s and Vision X's. We also have the CloudLens with App Stack. So now we're going to get into layer 7 analysis, a little bit of deep packet inspection, net flow generation. We'll be able to understand what are the applications that are coming by. Is this we're not going to look at IP addresses. Is this YouTube? Is this Facebook? Is this some unknown application? What's very convenient is you might have a malicious or unknown application running around in your environment, and we'll be able to dynamically learn that for you so you can set a filter on that one application and extract every bit of data that was relative to this unknown application that's running around in your network. We also have CloudLens with Mobile Stack. This is sorted, or let's say it's focused on the GTP control plane, user plane information. It comes with, again, just a lot of automation, and the UI has been built to allow you very quickly to get the job done on filtering on these levels. So the virtualized tap, again, we have the VMware support, Microsoft Hyper-V, KVM. And this is generally how we would see this situation. Once we have the CloudLens inside of your virtualized environment, the traffic will be sent to a service VM that we will use to then send the traffic out GRE, VLAN, or ER span to either a CloudLens sensor or to a packet broker, which would then send the traffic to wherever your tool farms are at. So in the containerized environment, we don't have the hypervisors, but we do have our own ways of being able to tap into this environment. So we can use the sensor vtap for monitoring application-based, or for application-based monitoring. This will be probably where we will fit into network function virtualization in the future, so that as we spin up multiple routers in our mobile environments to quickly deal with demand, because we also want to scale it down when we can, we'll need to have these sensors to be able to quickly go up and down as it's needed to and extract all that traffic for analysis. So as we were saying, you're going to have the application inside a container sitting at the top, and that traffic will be sent out GRE through your normal gateways and get to a packet broker or some type of aggregate source, aggregate point to send this traffic to your tools. Again, we have the Kubernetes tap. I'm just going to go on over this. Yeah, we've already talked about that. So some key points about the CloudLens sensor vtap. So the containerized vtap is that it runs as a Docker container in the Linux virtual workloads. It runs as an application agent in the Windows environments. It can be integrated in customer application management systems for easy deployment. Centrally managed for the CloudLens Manager and CSMP. So if you have a hypervisor environment and the containerized environment, you'll have a single point to manage this entire platform. It's very easy to use because of this metadata and group-based type configuration. We have captured and forwarding policies defined in CloudLens Manager and pulled from sensors. We're going a bit too far. So I'm not going to go through all of these diagrams. I don't want to make this too technical. I thought I had taken these out. Excuse me one moment. Actually, yeah, I think I missed my slide to go into the demo, but we can go ahead and do that now. So I'm going to share my screen so you can see the CloudLens SaaS. Give me one moment to switch. Okay. Okay, can everyone see my screen at this point in time? Claudia, can I get a quick check from you?
Yep, see it.
Okay, so at this point in time, we should see the CloudLens SaaS as we were seeing before. This would be where I would have the instances, either my sources or my tools. But to get started, this would be the first page you would see. You could have, for example, several projects where you would be grouping a lot of these instances. So if you, let's say we're a service provider or a system integrator and you were doing this as a professional services, you can manage multiple customers at the same time potentially. But as I was saying, we'll click in and now we have our demo environment here. So as we were talking about, I would have my instance on the left, which acts as my source, and I'll have my instance on the right, which acts as my tool. And this is where the traffic is going to send. Some key notes to say, I can do some very quick changes to to extract certain traffic. And I'm also able to send NetFlow from these devices as well. Now, this can be very, very, very important on the point of if I'm working in the public cloud infrastructures, and let's say I do not have a tool farm deployed at every single site. One of the larger costs inside of this public infrastructure as a service environment is data input output. So in some cases, for certain performance monitoring deployments, I would say, especially if it's a very multi-region, highly distributed environment, you might need to consider changing the way you're going to push traffic from the actual full packet to NetFlow, because this is going to reduce the packet information down to about 3% of its size. So again, if we're going to try to save money in the long term, this might be a good option for you. And it's very easy, as you see, just click the button and it's set to go. So while we're here, I built these VMs and I have one more sitting extra. So right now, I do have these two instances. So I'm pinging 888 Google right now, and that traffic is being sent across to my other virtual machine. But I thought this would be a fun little experiment for us. I have a fresh virtual machine, Ubuntu 18 server. It hasn't had anything installed into it, so I'm just going to go ahead and let's go ahead and do it. So as I was saying, one of the biggest, or actually the main or only requirement is that you'll be able to host Docker. When we go to deploy the system itself, it's going to have an automation script. So I'm mostly just going to come out here back to my environment. Let's go to launch an agent, and I'm going to have this deployment script. This deployment script will be downloaded, and this deployment script will download the CloudLens agent image. And as you would see here at the very end, I have this API key. The API key relates to your project. So whenever you log in and you have, it knows, or whenever the instance gets logged into the system, it knows who owns it. So I can copy that. Let's go back to my machine. All right, it seems like we're finished with Docker. I'm gonna right click and press enter. And now we should, there we go. So now we're gonna start downloading this image. Now, since we have this automation script in here, there's not gonna be anything else I'm gonna need to do. Once this image has been downloaded, and it'll be deployed right after it gets done, we should see it come in as an instance inside our CloudLens. Right now, the only metadata I'm really having for differentiation, just so you know, is that I have each of these CloudLenses just labeled as either CloudLens, CloudLens 2, or CloudLens 3. So when we go back to the other screen, we're going to go into the filters and find our CloudLens 3 in a moment. And then we will be able to define it as a tool group. And then I want to then push that traffic as we see with these other this other CloudLens endpoint. I'm going to push this traffic to this one, and we'll see this probably get done in the next 2 minutes, 3 minutes, hopefully. Everything always runs well during the demo, as we know. So while that's still deploying, I'm going to go over to my define group area, and we'll talk a little bit more about these this metadata. So the metadata we were talking about is all these little, say, keys. So information like who was the cloud provider. So on the instances I'm deploying are standard Ubuntu box VMs inside of my PC. If you were to deploy this from AWS, it's going to come with some extra information. So right here we see cloud provider as none, simply because I don't have an endpoint or an agent with a CloudLens provider attached to it. From there, we did grab the host name. So we were talking, as we were saying, I have CloudLens and CloudLens 2 that are currently inside. They're both running the Ubuntu operating system. So this can be convenient too for you grouping, let's say, a large number of boxes by, say, a specific build. Because you might have a specific build of CentOS to go with your application, and I just want to grab these, 200 CentOS boxes and put them all together. And using a little bit this filtering right here on this metadata key gets real easy for you. So again, let's keep gathering a little bit more information. Let's check on our VM now. All right, it says that we are deployed. It should just take another minute. Oh, nope, there we go. So now I see my CloudLens 3. I need to refresh my little filter area here. Okay. So I'm trying to define a new group or a new item of which I want to manipulate. So I'm going to filter on my CloudLens 3 to go ahead and drill down to that one item. I'm going to save this group as a tool. I'm going to call it my second great tool. Okay, so as you see, I now have a new second great tool that's listed on my monitoring tools area. So very easily, I'm going to grab this point and drag it to the other one, and it creates a connection. All right, the tunnel should be up now between these two locations, and I'm just going to do a TCP dump on the interface. I just need to make sure which interface it is real quick to verify it's there. Now let's try NP, or no, let's try the CloudLens. Couldn't remember which one it was off the top of my head. Not that one, so it must be the other one. All right, communication. Excuse me for this. So that was the communication with everything. I just want to see these pings. Let me just verify which one I used over here. I did use CloudLens. Okay, so let's try that again. And there we go. Okay. So now, as you see, within 10 minutes, we went through, let's say, installing Docker, deploying the, let's say, the deployment script so that it would automate the entire task for you. We got the instance into the web UI. We were able to group it into a new tool configuration point. And then we were able to now create a tunnel between these two locations. And as you see, this is a very, very simple process. So and that's kind of a big point to me. With all the new UIs and all the new applications and things that are out there, there's so much to learn for your engineers. We need to start to make things a little bit easier for ourselves because we're starting to go crazy from all of this stuff. So using these single pane of glass and using this automation, because your engineers know protocols and I'm going to say they understand how the theory works very well. And everyone might know a bit of certain brands depending on their work history. So if we go into a hybrid environments that are using multiple vendors, you could have a very, very solid guy who might come from Cisco, but he's not going to be able to configure AWS environment. And so this is where a lot of the applications you'll see from Keysight, from like here in CloudLens, is focused on just the reduction on the time, the engineering point, because you're just trying to get the job done. You want to be done easily, quickly, and effectively. So this would conclude my demo. I think we went through a little bit faster than I expected. But I hope you enjoyed it. And if you have any questions, please feel free to reach out to us. We'll be happy to set up a WebEx and we could look at this solution in your labs or maybe with one of your customers. Thank you for your time.
Thanks, John. And if anyone's got any questions, please use the chat window now. Oh, got a couple free, John. What are the limitation differences in cloud for, say, AWS VPC mirror service versus CloudLens? We've lost your audio again.
Apologies, I have such the habit of muting myself. So it's limitations. Not really. There's not too many limitations. I mean, they have a very similar situation. I want to say the end results is the same. At the end of the day, what's going to be different is just the configuration. What we're doing is building software to allow you to save all that hand clicking and hand work, because you know how to do it. We know you know how to do it too, but we want to reduce the time for you. So that you will not find a lot of limitations of maybe you could use AWS and that would maybe be enough for you. But if you're looking at multiple clouds, private and public, that engineer who's managing that one environment might not have it would be difficult to manage all these various environments. So we want to pull all that together. But no, there's not like a very, the only limitation would be if you, in a lot of cases, you put a packet broker on the end of that to do something like deduplication, and that could end up being a single point of failure.
Okay, and another one. Can you give an explanation on the cost implications of CloudLens, e.g. intra VPC versus inter VPC? That's one for you on the Monday.
Yeah, okay, so the cost, once again, actually, I think I could probably see the question. Let's see. I'm not able to see the chat. Why can't I see the chat? So Claudia, can you just say that to me one more time, please?
Yeah, explanation on the cost implications of CloudLens, e.g. intra VPC versus inter VPC.
I mean, it wouldn't, so there would be no cost difference. The whole licensing model is based off of your instances. So, you can get, you get these large, you can get a certain amount of instances, and that's what's important. If you used if you're going to using some AWS VPC, let's say extraction, moving that to your current network, you might not need as many sources. So that would be the point. If you're going to do a lot of the work in the configuration to allow some of that already, you might not need to have the extra sensors for these deployments. Because that's what this is really a lot about doing, is creating a tunnel between point to point and just completely automating that situation for you. As you saw, I didn't do anything but copy and paste a few different things. But now I have a secure tunnel between these 2 points, and I have all the traffic there. What I didn't have to do was spend 6 hours, working on that. And that would be, that's what it comes back to.
Okay, and looks like that's it for now. But if you guys have any further questions, please either reach out to myself, John, or your channel account manager. So I always say thanks for attending this session, and I hope you can join our session tomorrow. That's at the same time, and it's security in an encrypted world. Thanks very much for your time today.
Enjoy your day.